So this video is about derivative formulas. If it were always necessary to compute derivatives directly from the definition of derivative, as we did in the preceding section or the preceding lesson, such computations would be tedious and the evaluation of some limits will require some good old ingenuity and creativity. Fortunately, several rules have been developed for finding derivatives without having to use the definition of derivative directly. These formulas greatly simplify the task of differentiation. And let's start with the simplest form of all functions. So y equals a constant being some number. So if I had y equals, and for that matter, let's call it y equals c. And c represents a constant from this point forward. C represents any constant. So if I grab y equals, say, 5, that would look like this. At the number 5, there would be a line that would be horizontal. And this is the line y equals 5. Well, derivative means slope of the tangent line. The slope at any point on this line should be 0. So y prime is 0 because the slope at any point on that line would be 0 because it's a horizontal line. So y equals any value of c. Y equals c. Whatever the c value is, it's just going to be a horizontal line at that c value. And this is just y equals any constant. That's why it's called a constant. It's constantly the same thing. It doesn't change as x changes. It's just constantly whatever that number is. So that derivative is always 0. So this is our first derivative formula. It is d dx of a constant equals 0. And this is called the derivative of a constant formula. Again, as any constant. If I want to find the derivative of, say, -3, y prime would be 0. So the derivative constant is 0. I'm about to clear the screen now. So let's consider a different function. Let's consider y equals x to some n power, or n is some exponent. Define the derivative of this. The derivative is y prime equals to nx raised to the n subtract 1. Essentially, the powers rule allows you to take the exponent that was here, multiply the number in front, and then subtract 1 from the exponent. So again, this is called the powers rule. I suppose I ask you to find the derivative of y equals x to the third. Consider the powers rule. It should be y prime is equal to 3x to the second. Because we take the exponent, multiply to the front, and subtract 1 from the exponent. So use definition of derivative, that might take you half a page or more. But if you actually have this formula, it definitely saves you a lot of work, a lot of computational energy. Moving forward. So if y equals x to the 6th, then the derivative is 6x to the 5th. Give it another one. If f of x equals x to the 90th, then f prime of x equals 90x to the 89th. Consider another one. If y equals to w to the 8th, then the derivative of y with respect to x is 8w to the 7th, or dy dx is 8w to the 7th. One last one. d dx of z to the 5th power is 5z to the 4th. And d dx just means derivative. That means derivative. dy dx means derivative. F prime means derivative. Y prime means derivative. All those are different ways you will see derivative. They just mean take the derivative. Or that's what derivative equals. Moving on. So the next rule is the constant multiple rule. It means d dx, or derivative with respect to x, of some constant times some function. So like 3x squared, or 5x squared, or whatever. You could take the constant out and multiply by the derivative of whatever the function is. So that basically means that if I wanted to find the derivative, I suppose I actually define the derivative of 6x to the third. Basically that means you can take the 6 and then multiply by the derivative, x to the third, well, that's 3x squared. So the answer would be 18x squared. So if you want to take, that's what the constant multiple means. You can move the 6 out of the way for the moment and take the derivative of the function and then multiply it later. Or if you just know 3 times 6 is 18, that's fine too. And that will work as well. All right, moving on. All right, so the next one is the sum rule. So the derivative of the function f of x plus g of x is written as the derivative, so d dx of f of x plus d dx of g of x. Or more simply, f prime of x plus g prime of x. Saves you a little writing. Just consider it, call it f prime plus g prime. And that's true. That's the derivative of the addition of polynomials. So basically, the different rule says essentially the same thing. I want to take the derivative of h of x subtract g of x. I basically find h prime of x, and I subtract m prime of x from it. So h prime, derivative of h of x subtract m of x is h prime of x subtract m prime of x. So it's pretty much works a lot like the sum rule. All right, new one. All right, so next one is the product rule. Basically, I want to take the derivative of f of x times g of x. It's basically f of x times g prime of x plus g of x times f prime of x. So a little bit more to it when you multiply them. There's more to it than when just adding them. So this is the rule, this is the formula for finding the derivative if you got a product of two polynomials. All right, let's go on to the new one. All right, and the final one we're going to talk about today is the quotient rule. The quotient rule says that if f and g are differentiable, then the derivative of f of x divided by g of x is basically g of x times the derivative of f of x subtract f of x times the derivative of g of x divided by g of x quantity squared. So if you got a division, it's a little bit more work, but it's pretty easy as long as you stick to the formula. All right, let's go forward. All right, so in this example, it says find the derivative of each of the functions using derivative formulas. All right, so we want to find y prime and y equals to this. So if I want to find y prime, I know this for sure. Y prime should equal to 5 times this derivative. So 5 times 2x to the first, which is 10x. That's the derivative of it, it's just 10x. The second one says find the derivative of 16x. So y prime would equal to, exponent here is 1, so 1 times 16 is 16. Subtract 1 from 1 gives you 0. It gives you 16x to the 0. You should know at some point that x to 0 means 1. It means 16 times 1. Or more simply, equals to 16. So if you see the derivative of a linear function, it's just going to be the coefficient. So just for good measure, just talk about that for a moment. I'll give you y equals x. If I want to find the derivative of that, it's just a coefficient 1. If I gave you y equals to 17x, just coefficient, it's just 17. So when you take the derivative of a linear function, it's just the coefficient. If you take the derivative of a constant, it's 0. So those are two simple things you can find pretty easily. All right, I'm going to erase some of this stuff because I need more space for the bottom one here. All right, so let's go on. All right, so we're going to find the derivative of this polynomial. So f prime should equal to the derivative of each one of these terms, according to my sum and difference rule. So the derivative of x to the third is 3x squared. Derivative of 2x squared is 4x to the first. The derivative of negative 4x is negative 4. And the derivative of the constant is 0. So you can put plus 0 if you want. I won't bother. Just plus 0. So that's the derivative of it. All right, give me a new one, new set of questions. All right, new question number 4. So you can pause the video if you want, and you can try using the product rule. But we'll first talk about the product rule, then we'll talk about it some other way. But you can pause the video, we'll talk about 2 ways of solving this one. I'm going to explain it now though. So if I want to find y prime here, y prime would be the first function times the derivative of the second. So it would be 3x squared times the derivative of the second, which would be 15x squared, plus squared. So plus the second function, 5x to the third, times the derivative of the first function, which is 6x. So this would give you a product of 45x to the fourth, plus this is 30x to the fourth. You technically add those, and you add that up to be 75x to the fourth. So y prime, or the derivative of that function, is 75x to the fourth. You might could have noticed that we could have multiplied these together first. And if we had multiplied those together first, you would have had a simpler problem. So if you multiply together first, it would have been 3 times 5, which is 15. And then x squared times x to the third is x to the fifth. So that's equal to y. So y prime would be 15 times 5x to the fourth. 15 times 5 is 50, and 25, yep, that's 75. X to the fourth equals y prime. Saves a little steps, a few steps, but I just want to talk about how to use the product rule. Yeah, you could have solved that either way. All right, one more. All right, this is the last example using the rules I just gave. After this example, I'm going to give you one more. It's not really a new rule, it's just a new way of thinking about a rule. But anyway, it says find the derivative of this function, and this is definitely quotient rule. So f prime of x should equal to, it should be the denominator times the derivative of the numerator. So the derivative of that should be 2x plus 3. Subtract the numerator times the derivative of the denominator. So that's going to be 1. That's going to be over the denominator squared. So this is what it is. Could you fold that together? Yes. You can fold all of it together, combine like terms. I'm stopping there. That is the derivative of it. But again, you could fold it together and get a simpler answer. I expect you to. For the sake of time, I won't. Go on. All right, let's consider this one. It says y equals 1 over x squared. You might think it's quotient rule. Yeah, you could try the quotient rule with this one. It should work. However, if you think about this a different way, this is the same thing as x to the negative 2. Y equals 1 over x squared is equal to x to the negative 2. So that's true. When I find the derivative of y equals x to the negative 2, that's going to equal to, hold on, let's make that look a little better. That's going to equal to negative 2x to the negative 3. So if that's true, I could rewrite this as negative 2 as the numerator, and that's divided by x to the positive 3. All right, so the derivative of that would be negative 2 of x to the third. But again, we thought about it as a quotient rule. It would be, the derivative would be the denominator, so x squared times the derivative of the numerator. The derivative of 1 is 0. Subtract the numerator times the derivative of the denominator, so that's going to be 2x. And that's divided by x squared squared. So it gives you 0, subtract 2x, numerator, x squared squared is x to the fourth, and that reduces to be negative 2 over x to the third. So yeah, you could have did it with Powers' rule, with the quotient rule, but it might be easier to think about this as a negative exponent and then solve it there. A lot fewer places to make mistakes. All right. Our last type. So suppose I gave you y equals 1 over the square root of x. I want to find y prime. So our first thing about the square root of x as an exponent. So that means x to the positive 1/2. Square root means raised to the 1/2. So this means x to the negative 1/2. And again, all the ones I used so far had 1 on top. If this was a 4 in front or whatever, it'd just be a 4 in front of the x. If this was a 4 in the numerator. So if you got numbers on top of yours, don't let it throw you off. It's just going to be now a coefficient when you bring the exponent up. When you bring the variable up. So anyway, just get that out of the way. So if I want to take the derivative of that, it should be negative 1/2 x to the negative 1/2 subtract 1 should be negative 3/2. So it should be x to the negative 3/2. So that gives you negative 1/2 times 1 over x to the positive 3/2, which means negative 1 over 2. Let's go call that the square root x to the third. So that will be the derivative of it. So that's how you do it. That's all I have. Good luck.